Okay, so we have this problem is like a firing type problem. If we're going to list our facts, then what I would suggest you do is you use letters instead of numbers. It's easy to keep track of what mass you're talking about if you have it identified with a letter. So it says, Mr. T ignites the enthusiasm of the class with a homemade cannon demonstration. The 1.27 kilogram cannon. So I'm going to have a cannon and I'm going to have a tennis ball. So I can use B or T. I'll use T for tennis ball. So those are my two masses. Now, if you look up above, you've got the cannon in kilograms and you've got the tennis ball in grams. So I can either keep them both in grams or both in kilograms. I guess I'm used to keeping things in kilograms, so I'm going to do that. So that means that the mass of the cannon is 1.27 kilograms. If I did do it in grams, it would be 1,270 grams. Well, if I'm going to have that in kilograms, then that means that my mass has to be in kilograms. So I need to move the decimal point 3 to the left because it's 1,000 grams in a kilogram. So my answer there will be 0.054 kilograms. Now, before the explosion, the velocity of the cannon and the velocity of the tennis ball are what? What are their velocities? Before it explodes, what are they? 0. So we have 0 meters per second for both. So that means I don't have any momentum before the explosion. If I don't have any momentum before the explosion, then the sum of my momentum after the explosion has to still be 0. All right, you could have an example where there is a momentum before and it would still be like firing. I'll give you an example. When you do it like a figure skater, one of the problems they have is two figure skaters are skating together. And then one figure skater throws the other one forward. Well, before he threw the other figure skater, they did have momentum. So the momentum after would not be 0, it would be some other value. So in this example, we have these three numbers, and then the other two numbers that we need. We need the velocity of the cannon after the explosion, and we need the velocity of the tennis ball after the explosion. Now, the one that we're looking for is the speed of the ball. So the speed of the ball would be the speed of the tennis ball. That's going to be in meters per second. And the velocity of the cannon, it's a recoil velocity. So it says recoiled backwards. So what is the sign of the velocity? Negative. So you should be writing down, let me see if I can get this out of there. It's going to be negative 7.8. So those are your facts. If these are the facts, this is a momentum problem. We're going to write down the law of conservation of momentum. M1 V1 plus M2 V2 equals M1 V1 prime plus M2 V2 prime. And the momentum of the cannonball and the tennis ball, the cannon and the tennis ball, are both 0. And notice I used ones there. I should have probably used C and T because those are the variables. But I'm going to use C and T in this next step. So if I'm solving for the velocity of the tennis ball after the explosion, then that's really, let's say I'm calling it this. So that's VT prime. So what I'm going to do is I'm going to move this one to the other side and then divide by the other end. So the other one, what I have here is M1 V1 prime. That's the cannon. So that should be M cannon V cannon after explosion divided by M for the tennis ball. And really, I made it hard on myself by going and putting 1s and 2s here. I just automatically wrote it down because that's the way the formula is usually written. I probably should have written them in the 1 and 2s in terms of C's and T's. So this would be my step 3. So my step 4 is the velocity of my tennis ball is going to equal the mass of the cannon times the velocity of the cannon after the explosion divided by the mass of the tennis ball. So the mass of the cannon is 1.27 kilograms. The mass of the tennis ball is 0.054 kilograms. The velocity of the cannon after the explosion is negative 7.8 meters per second. So look what happens here. You've got whoops, I'm missing something. I'm missing a minus that should be there. Does everybody follow that? I'm missing the minus because I moved this to the other side. So if it was a positive term on the right side, when I move it over, it's going to be minus. So that minus needs to be there, and there's the minus there. So I have a minus times a minus, so my answer for the velocity of the tennis ball will be positive. So if you work that out, you get the velocity of the tennis ball after the explosion is 100 to 3 significant digits. It's 183 meters per second.